Okay, so I'd like to talk to you about whole numbers, integers, and rational numbers. We've already done so, but we've done so in terms of a number line. So let me just start with that, and then I'll move to this diagram, which I'd like to show can also represent categories of numbers that we've already been talking about. So if we were to talk about a number line, let's say it starts at 0 and it goes all the way up to positive infinity by 1 unit at a time. 0, 1, 2, 3, 4, all the way to 1,000, 1,000,000, all the way up to positive infinity, all of those are considered whole numbers. No fractions are included, no decimals are included. They're starting at 0 and all the positive numbers that aren't decimals or fractions, unless, huge unless right here, unless those decimals or fractions can be reduced back down to whole numbers. For instance, 24/12 is a fraction, but it also can reduce down to 2. 24 divided by 12 is 2. And 2 is a whole number, so 24/12 is also a whole number. All right? So let's now broaden our horizon, so to speak, and include all integers. So integers, do you see, is a circle that includes whole numbers. Whole numbers are not only just whole numbers, but they are within a subset of integers. So integers includes all of the whole numbers, as well as the opposites of those whole numbers. So going back to our number line, if you can think of the 0 line, the 0 hash mark, as being a big old mirror, and then the reflection of all of these whole numbers are going to be their opposites. So the reflection of 1 is -1. The reflection of 2 is -2. So basically, we have all of our whole numbers and their reflections and their opposites, okay? Those hash marks, 0, 1, 2, up to infinity, as well as -1, -2, down to negative infinity, all of those numbers are considered to be integers, okay? So if you have a negative number, you can put that in the integer spot, as long as, again, there's no fractions or decimals, unless one of those fractions, like -24/12, can then be divided down to -2. And -2 is an opposite of 2. It's a negative number. It's an integer. Okay? So going on to expanding our horizons even more. So whole numbers, all whole numbers, are integers, and all whole numbers are also rational numbers, okay? So rational numbers includes integers and whole numbers, but rational numbers also includes numbers that aren't whole or integer numbers. Rational numbers include everything, all the circles that are inside, that's why all the circles are inside rational, plus fractions, and certain types of decimals. And so we're going to say decimals, special types of decimals. The decimals that, we're going to say decimals that either end, we call that terminate, or repeat, okay? So decimals are rational if and only if they either end, meaning they terminate at some point, like 0.24, stop. Or if they go on forever, they have to repeat. So for instance, 0.245, 245, 245, 245, all the way for infinity. That would also be a rational decimal. So decimals can be rational as long as they follow one of two of those rules. And then all fractions where they are in this m over n form, where both the m and the n are both integers themselves, you've got yourself a rational number. So, long story short, we have different groups of numbers, and each group of number, it looks like it expands to include even more numbers. So there's a lot of ways that you can play around with this. For instance, here's a question. Are all integers whole numbers? Are all integers whole numbers? Well, you see that some integers are not whole numbers. Some integers like -1, -2, -3 aren't included in the smaller circle. So since you can find examples of integers that are not whole numbers, it is not a true statement. It is not a true statement to say that all integers are whole numbers. How about this? Are all whole numbers rational numbers? Yes. See? Because whole numbers, the entire circle of whole numbers is within the much larger circle of rational numbers. So this is a really useful tool, I think, a visual tool to be able to answer some of these conceptual questions. Thanks.